Welcome again. My name is Lizeth Lopez. I'm a project manager at the Environment and Climate Hub in ALDA, and I will be your moderator today. The final goal of this training is to introduce you to an overview of the Buildspace backgrounds, objectives, and potential opportunities for applications. In particular, for this specific training, we will present the features of Pilot 3, which is Piraeus, together with the technologies used in the development of Service 4, urban heat analysis and resilience. So I would like to first give you a brief overview of what we expect in these next 2 hours. For our agenda, we're going to start with some overview regarding the project. We're going to go in depth regarding the key concepts of urban heat analysis and resilience. We're going to see some insights regarding the service and its European replication. Then we will go and see the pioneering smart solutions for energy efficiency that the service and the project provides. Then we will go regarding the challenges and the strategies for a sustainable and resilient Piraeus. We will see the service for in action for Piraeus regarding the benefits and the experiences from the ground. We will have a short coffee break or a short pause for our online participants, and then we will come back to have a live demonstration of the service in which each of us will be able to experience the service itself with a guide of our service developer, of course. We will have some space for questions and answers regarding the services, the use, or any particular concerns you may have. And then we will give a closure to the event. So before we go really into depth into the project or into the project service, I would like to introduce very briefly of what is Buildspace. Buildspace is a 3-year project that aims to support the Green Deal objectives. We are a consortium of 14 partners, and the goal of Buildspace is to couple territorial data from buildings with aerial imaging from domes, equipped with thermal cameras and location annotated data from satellite services. Our donor is Horizon, is funded by the European Union, and regarding the time frame, Buildspace finishes in January 2026. So Buildspace will develop a platform which allows the integration of heterogeneous data and will offer 5 decision support tools, which we call the services. So today's event regards the training of one of these services. These services are, we have services at the building, at the city level, and that they are key for the development and for the support of different key stakeholders in the construction, renovation sectors, urban planners, city authorities, NGOs, SMEs in the space, building, energy industry, as well as policymakers and researchers. Why are Buildspace services so relevant? Because as we've seen, urban areas face increasing climate challenges, such as heat waves and floods. The decisions that our authorities or us as citizens do must be informed by accurate, spatially aware, and scalable data, and that's where Buildspace comes into place. Buildspace delivers tools that integrate Earth observation and AI to support cities and stakeholders. So with this short introduction of Buildspace, I would like now to introduce our 2 distinguished speakers today, whose work bridges innovation, research, and real-world impact in the fields of urban resilience and digital transformation. So first, I would like to give a big welcome to Patricia San Nicolas Vargas, who is an architect and predoctoral research at the Universidad Politécnica de Madrid, specializing in urban heat and climate vulnerability. With a master's in environment and bioclimate architecture, she has contributed to both earthquake housing rehabilitation in Chile and participated in several EU-funded projects tackling energy poverty and urban climate through a social lens. Patricia is joining us online today, and then we have a representative on site, who is Michael Burmpus is the Director of Informatics at the Municipality of Piraeus, where he leads digital innovation and smart city initiatives. With over 2 decades of experience in IT and a PhD in computing and telecommunications, he has spearheaded multiple EU-funded projects in e-governance and digital infrastructure, blending academic expertise with practical solutions in public administration. So these are two special guests today and who will guide us through the experience in Piraeus and the service itself. Without nothing else to add, I would like to give the floor to Patricia, who is gonna start immersing us in this world of the service for. So Patricia, the floor is yours.
Okay, thank you. Good morning, everyone. Thank you, Lisette, for the introduction. I'm going to share now my screen. I believe that everyone can hear me, right? Yes? Okay, perfect.
Yes, we can hear you.
Okay, so now you can see my screen, right?
Yes.
Okay. So thank you for the opportunity to share the work that we have been doing in the context of this European project, the Buildspace project. And now we're going to begin with the presentation in this live event for the smart tools for urban heat challenges in Piraeus. So for today's agenda, I'm going to start first with some of the key concepts related to urban heat. And then we're going to review some insights and replication guidelines for the service. Then we're going to look into the technologies that we have been using to deploy this service and some conclusions. And then later at the end of this event, we are going to, everyone is going to have the chance to test and see how it works, the service for application in our demo session. Okay, so with the key concepts, I would like to start with this one, the climate change, that I imagine that everyone here present today knows or has an idea of what it means, climate change. But what I would like for you to take away today is that it refers to a long-term changes in temperature and how this affects climate patterns, okay? So it's not about when we face an anomaly in temperatures during a day or during a week or even during a month, rather than some anomalies that we can observe in a long term. And because of that, it has the capacity to affect the climate patterns. It is mainly driven by human activities, especially because of the burning of fossil fuels, which leads to global warming, rising sea levels, and extreme weather events. At the right, you can see a graph that I took from the Copernicus Climate Change Service. And this is a global temperature trend monitor. And it basically predicts when we are going to reach the threshold established in the Paris Agreement of global warming at 1.5 degrees. So by the time that I prepared this presentation, the predicted date was June 2029. And just yesterday, for curiosity, I checked in this again. And now it has moved to May of 2029. So I think this is very interesting. So I encourage you to check on this global temperature trend monitor. Now, regarding cities and climate change, here in this video, this is Madrid, and we are looking at the hourly evolution of intra-urban temperature variability. And so you can see how the urban heat distribution changes across different times of a day. Here you can see the hours, and also how the intensity concentrates more in some areas than others. For example, here you can here we have a large park, which is El Retiro, and you can see how some of the temperatures, some of the lowest temperatures can be found here, especially during the nighttime. So we need to understand how this works, what is happening here, and which are the variables that have a main role. So regarding that, we have first the city surfaces. So we know that in our cities, we have a decrease of permeable surfaces, which affects the water retention. And also the materials that we are using in the construction of our cities, they may present some characteristics that contribute to heat retention within the city. And of course, we have less green areas. We have less naked soil in our cities. So that also contributes to have higher temperatures. We have the anthropogenic heat, which is the heat emissions from human activities, such as transportation, cooling systems that are taking all the heat from the inside of the buildings, but then we are moving all of this heat to the outside, so we are contributing to all of these higher temperatures. And of course, we have the industry. And then the urban design also plays a major role because the layout and the geometry of the urban fabric can determine how solar incidents in the built environment, and also can affect the airflow, decreasing natural ventilation, which is one of our most known passive strategies for cooling. Now, regarding the urban heat risk, we have been working based on the concepts that are established within the last IPCC report, the AR6. And this is a figure of how is constructed the risk. So we have the risk at the middle, and then we have in the outside, we have its three determinants. So first we have the hazard, then we have the vulnerability, and then we have the exposure, and we can see how they can interact between the three of them. So what is risk accordingly to these to the IPCC? So it's the potential for adverse consequence for human or ecological systems, recognizing the diversity of values and objectives associated with such systems. So it can arise from potential impacts of climate change, as well as humans' responses to climate change. So in the context of our service, in this case, the hazard, it's understood as the urban heat. That's our hazard, which is this one. Hazard is understood as the potential occurrence of a natural or human-induced physical event or trend that may cause loss of life, injury, or other health impacts, as well as damage and loss to property, infrastructure, livelihoods, service provision, ecosystems, environmental resources. So now we can start relate how urban heat can affect us and also our environment. Now, regarding the exposure, is basically what it is exposed to this hazard. Okay, so this is the presence of people, livelihoods, species or ecosystems, environmental functions, services and resources, infrastructure, economic, social, or cultural assets in places and settings that could be adversely affected. So this is very important to understand, and depending on the hazard, what can be affected by it. And lastly, we have the vulnerability, one of our most important determinants of risk, which is basically what makes us propense to be affected by this hazard. So it's the propensity or predisposition to be adversely affected, and encompasses a variety of concepts and elements, including sensitivity to harm, and lack of capacity to cope and adapt. So for this vulnerability assessment, we have been working with socioeconomic and demographic variables, because it's how we can be more predisposed to be adversely affected by the hazard that is the urban heat. So what can we do about it? So first we can adapt, which is the process of adjustment to potential damage and to take advantage of the opportunities that we have in front and to respond to consequences. We can also mitigate through actions and activities that can limit the emissions of greenhouse gases. And we can also be more resilient, which is the ability of the system to anticipate, reduce, accommodate, and recover from disruptions in a timely, efficient, and fair manner. And from the perspective of heat and the urban heat, what can we do? We can evade, we can reduce, we can collect heat, and we can deviate heat. So to evade heat, it refers to strategies designed to prevent heat transfer by blocking or minimizing heat gains from both external and internal sources. So we need to protect ourselves and the buildings from the solar radiation so we can avoid the overheating in insides. We can also reduce heat, which focuses on dissipating accumulated heat from buildings or urban environments using both passive and active techniques. I like very much this image because we can see here a combination of passive and active strategies. First, we have the sunshades that are providing shades in the here, and also we have these water misters that contributes to reduce a little bit the air temperature. Then, of course, we can use this energy that we are receiving and capture solar energy through technologies such as solar thermal panels or photovoltaic systems. And also we can deviate heat by manipulating the flow of thermal energy through passive means, for example, working with the materials thermal mass or insulation. And now we're going to see the insights from Service 4 and its European replication potential. So as Lisette already said in the introduction, Buildspace has developed a total of five services, and Service 4 is one of the 3 city-scale services, which is called Urban Heat Analysis and Resilience. In this service, we aim to examine the urban heat intensity and distribution with a high spatial resolution at the same time that we are taking into account vulnerability factors in order to determine the urban heat risk under the present and the future climate scenarios. So for the Service 4 functionalities, what can we offer? We offer the urban heat risk map with statistical information at census tract scale. We also have the hazard, vulnerability, and exposure maps, which are the 3 determinants of risk that we talked about before. We have the delimitation of hotspots, identification of priority areas for intervention, which is very important for decision making. And we have future climate scenarios and weather files for energy building demand analysis. We have the estimation and map visualization of the current energy demand of the residential building in stock. And we offer a decision support tool with possible actions, adaptive solutions catalog to provide a guide on how to achieve more resilient cities. Now let's talk about the replication potential of Service 4, because we actually need data. So in order to calculate the urban heat and its 3 determinants, we need, by the side of the hazard, we can rely on official monitoring networks that can be at different scale. For example, local, regional, or national. But we can also use the non-conventional monitoring networks, such as the citizen weather stations. We actually worked for our pilot, Piraeus, we worked with these stations, and they turn out to be really good. And for the vulnerability, we have the socio-economic data, such as income, level of education, unemployment, people with no house ownership, women as breadwinners, and women as single parents, and some demographic data, age, immigrants, and gender. We need to understand that all of these variables are important in order to calculate the urban heat risk. And all of this data can be found on Eurostat, but also on national level databases. And for the exposure, we work with demographic data, specifically with population density, but also with building data, such as building energy performance, year of construction, buildings characteristics. And very, very, very important, this part, the spatial resolution. For the Piraeus case, we have been working with a census tract. We weren't able to obtain the information through the database of Eurostat. So in this case, we actually obtained this data from the national database. So it is important to have this spatial resolution because that will enable us to detect the most at-risk neighborhoods within a city. So if we do not have that data at that spatial resolution, we are not going to be able to determine the urban heat risk, okay, at this spatial level. The means that that we use. So first, we have the Service for Application tool that is a user-friendly web-based tool in which we have uploaded all the results from all the analysis of related to Service 4. So any user can log in and explore and see the results and see how to apply the Service 4 application. But also we provide the option to download, for example, shapefiles, which are a format used in GIS software, and you can use them in open source software such as QGIS, but also ArcGIS Pro. The last one is you need to pay. And then lastly, you have the weather files that we have constructed for the current and future climate scenario. And if you are working on the building energy model, you can use these weather files that are specific for these areas and use it for this modeling. Now let's talk about the pioneering smart solutions for energy efficiency and urban resilience. So for our service, we use data from the Copernicus Land Monitoring Service, and specifically the NDVI, which is a vegetation index that tells us where we have the green areas and that they are healthy. And then we have also here in the middle, we have a digital elevation model because temperature changes accordingly to the height. And also we have the current land cover, which sets the different types of land use within, in this case, the Athens metropolitan area. And from the Copernicus climate change, we have used the ERA 5 hourly data, which is, in this case, this is the 5th generation of the ECMWF reanalysis. And this information is available for the global climate and for the past 8 decades. And this is very useful because it's updated every 5 days, and it has also a really good spatial resolution, but also a very important hourly temporal resolution. Regarding also the climate data, as I said before, we base our analysis of the severity, the urban heat severity, by using these non-conventional monitoring networks, which are collected from citizens that they upload to a network. And one of the good things about this is that they have a really good high spatial resolution, and we can find it almost in the major cities at the European level. But one of the challenges that we have faced using these networks has been that we have to apply some quality controls and quality assessment controls, but we have accomplished this satisfactorily, and also we have found data gaps, but this was also overcome. And this was made by using Python programming. So we have automized almost all of the process. And also we have been working with artificial intelligence, specifically with neural networks, in order to construct these weather files for the future, well, current and future climate scenarios. And also we rely on GIS software in order to make some of the calculations to obtain the results for the determinants of risk. To finalize some of the main conclusions is that extreme heat in urban environments is not only a climate challenge, but it's also a social and territorial use issue. And Service 4 demonstrate how to transform complex data into accessible tools for more informed and equitable decision making. So thank you very much for your attention. And lastly, I would like to mention my UPM team, because of course this is not possible to do by only one person. So I would like to mention to Miguel Núñez, Peiro, Carmen Sánchez, Guerra Sánchez, Sofía Lado, and myself, of course, Patricia San Nicolas. So thank you.
Thank you very much, Patricia, for this introduction. Now, I would like to invite you to our second speaker, which is Michael. He will introduce about, he will speak about experience from the municipality regarding as being a pilot, as well as use of the service. So, Michael, the floor is yours.
Hi, can you hear me?
Yes.
Okay, so I'm Michael Burgos. I'm the director of informatics for the Municipality of Piraeus, and heading the Buildspace project for Piraeus. Let me give you one moment. Okay. First of all, we start regarding the challenges and strategies that Piraeus has in place for sustainability and resilience. Let me give you an overview of Piraeus. Piraeus is one of the most densely built cities in Europe. It is reported that we have around 15,000 citizens per square kilometer. We have very limited green space, 1.5 square meters per capita. The fifth municipal district is, if I'm not mistaken, the area with the less green per capita in Europe. We are also a former industrial area, at least parts of the city. We have 11,000 acres of abandoned industrial areas, some of them under renovation, some of them under plans to be renovated. We think that there exist intense urban heat island effects in the city because of its topology and morphology, but mostly because of the density of construction. And as a port, the per capita income and a lot of vulnerability indicators are rather so high sensitivity to heat effects. As we said, Piraeus is a major European port city, so it comes with all the problems that a port gives to the city. And based on what happens in the world, we are also seeking for climate resilience for our infrastructures, and also for some innovative ways to perform some green transformation, because there are specific problems that some say that cannot be overcome. Data that are available in the municipality come from the Hellenic Statistical Authority, mostly, but also from other sources like satellite information or private initiative collected data sources. In the last 5 years, we are also trying to collect as much information as we can from sensors. So there are also 5 stations that measure air pollution and meteorological indicators, but also 2 sea water pollution sensors as well for the 2 beaches in Piraeus. The way that climate change is happening, from what we saw from Patricia, we have come to a point that we need fast and actionable data and insights on this data in order to counteract the climate change. Regarding the city strategic goals for resilience, as we said, we need to know what's happening. So we need to integrate data, produce the climate risks, and integrate them into the city planning, into the strategy. As a side effect, we need to improve on energy efficiency for our own infrastructure, but if possible, to give initiatives to the private sector as well in order to improve energy efficiency. We have to expand our green zones in order to reduce heat vulnerability. This is something that we are working on, but we face specific challenges because there are limited areas that we can use in order to expand these green zones. And because the economics is always a key factor, we are trying to pursue every European funding opportunity in order to support these endeavors, either by some innovative solutions to apply, or in order to actually do this infrastructure work. We heard about the Service 4 and the Buildspace project. For Piraeus, it's an EU-funded initiative, basically funded by EUSPA, the European Space Agency program, because we want to exploit the data that the European agency is collecting through the Copernicus system. So they are our main source of funding, the project's main source of funding. We are involved in another service also, Service 1 and Service 2, that is specific to buildings. Service 4 is a risk analysis tool that we are involved in, and we want to see how we can use this tool and include it in our strategy. This tool helps us visualize complex information, and based on this information, create some vulnerability maps that can actually help us design the actions, but also decide on the areas that need the interventions. This way, we are enabled to better use our data sources, but also our resources in order to maximize the impact. So what has happened in these 2.5 years that we are working in the Buildspace project? Service 4, as we said, is an urban heat analysis and resilience service. You will have the chance to see it in action in a few minutes. In order for this to operate and be built in the best way possible, some socio-demographic, energy consumption, and climate data are required. Are required from the city of Piraeus to the technical partners and mostly UPM that is building this. We have provided UPM whatever was available to us, so we have given some socio-demographic data received from the Hellenic Statistical Authority, but also some information that we had. As a lesson from the ground, unfortunately, the data that are complete, let's say, in this aspect are the 2011 data. For 2021, we had to go into a very time-consuming procedure where we could get the data, but we didn't have them at the beginning, let's say, of the project. So this is something that, for as lesson learned, is something that we need to take into account for other projects or other endeavors. Regarding energy and climate data, we have given whatever was available to us, but also the data from the Copernicus system was already available to our technical partners. And as Patricia said, the GIS information, the spatial information were also collected from the Hellenic Statistical Authorities and were given. For the energy part, we have very few information. The analysis needed to happen for the whole city. So we needed to reconstruct, let's say, some information from the buildings. Unfortunately, Piraeus had data available only for part of the city, not for the whole city. So we produced this data, and also this data were private initiative information. They were collected from the National Technical University of Athens for specific, let's say, districts in the city. So there were gaps in the city, in the data that we had, where UPM helped us run a mapathon with, I would say, low to medium effect. We didn't manage to cover the complete city, but we saw that we can actually do this step by step when involving people. However, again, as a lesson learned, we are way behind as a country in some aspects regarding the building census, the building cadastre. Thankfully, from what I have heard at least, we are in the process of mapping the infrastructure dynamic of the whole Piraeus and of the whole city through the technical chamber of Greece. And hopefully in the next couple of years, we will have a complete database that we can exploit without having to rely, let's say, on private initiatives or other means in order to collect useful information. Using all this data, our technical partners generated the predictive models for current and future heat risks and produced vulnerability and resilience, let's say, maps and visuals at city level, at neighborhood level, based on which hopefully we can act upon. So how Piraeus used Service 4? First of all, the heat islands and socially vulnerable zones were mapped. You will see in the demo that we have the whole of Athens mapped in terms of heat, if I'm not mistaken. The social vulnerability comes only for Piraeus. We have and we plan to use it more across our urban planning, building, and also our green departments that might be able to act upon these maps and try to reduce the effect of heat islands within the city. Supported the discussions in municipal crisis response and green planning units are to be held based on this information. And we have used this tool as a decision support tool, but basically as a first level test of the tool, let's say, in order to reach the stage of actually using it as a decision support tool, as I said, for the past 2 months. The added value for the municipality, Service 4, the Buildspace web app for Service 4 enables us to have immediate access to key resilience stats, let's say, per area. It helps us integrate vulnerability and heat data into one visual platform, into one map, let's say, so we can combine this information. And we think that this is highly useful for departments relevant to our infrastructure, to urban planning, to green planning, but also for public safety and crisis response for our civil protection department. The plan is to have this web application here in the operation center of the municipality, where we can link the information from this tool to sensor data and other information and from other platforms that are on the video walls of the operation center. And having said this, an idea could also be that the Service 4 could link with the real-time sensor data to provide alerts, trigger emergency response, as an additional information, let's say, to the live data feeds that are coming in here in the municipality's operation center. Having this data in here also helps us probably coordinate and support the interdepartmental coordination, where also as a lesson learned from Buildspace, there is a lack of coordination. An example for this is that in the municipality, we have run several projects regarding climate change and urban resilience. But sometimes there are projects run by one department and projects run by another department, and these two cannot combine to provide another value that could be of use for the municipality. In the beginning of this project, the basic problem of the departments is that it's not very clear in the early stages of the project what exactly is going to happen. So in our case, we had two Horizon projects running in parallel. That one was regarding heat islands, let's say, and the other one was about, if I'm not mistaken, climate change in general, Harmonia project.
Yes.
Climate change in general. So these are two projects that could have combined. However, the actual results of these two projects came at the end of the project. So there was no room, let's say, for producing, combining this project and producing some added value out of them. Our next steps, we need to work on integration, both for our sensor live data and also our platforms and more, let's say, decision-making tools as the Service 4 from Buildspace. We need to work on our cross-departmental coordination and engagement. And we need also to seek for more funding opportunities in order to better formulate our strategy regarding climate change. Okay. Να δεν γυρίζω. So that's it for my side.
Thank you very much to Michael and to the Municipality of Piraeus for these insights regarding the use of the service and how it can be put into action, not only for Piraeus, but maybe for other potential cities that would like to replicate the service in their areas. I think with this, we have this first part of the webinar covered. We have trying to go over the main key terms and to put you on the place of the use of the service to align our knowledge. And then what we're planning is to do the hands-in session in which you will be able to explore the service yourself. But since we're a bit early in our agenda, I think we can take now our coffee break or short pause of 10 minutes. Also for our participants in presence to be able to have a bit of a break, and we will come back for the demonstration session. So we will have this pause and the webinar will restart at 11:05. Thank you, everyone.
So welcome back, and now we are going to check the Service 4 application. And the idea is that you can see it by yourself and interact with it. And so I don't know if there's anyone missing that hasn't already upload this application. Everyone has it?
Yes, we're set.
Okay, so I will stop sharing this and I'm going to share my other screen so we can go in the same. Okay, so this is the service for application. When you enter for the first time, you will see this welcome window, which says that this is a tool to assist you in detecting the areas most at risk from urban heat, and that it will also support you on discovering locations with the greatest potential to mitigate urban heat and increase the resilience of your buildings and their immediate surroundings. So here you have two options. You can access directly to the application, or you can do the full guided tour. Okay, so for now we are going to close this window so I can explain you the structure of the application. So in the upper side of the screen, you'll find this menu. The first option here, we have the diagnosis, where you can find all the maps and results regarding the urban heat risk calculation, and also the three determinants of risk, which are the hazard, the exposure, and the vulnerability. And also we are going to have this climate scenario option to select. And then in this other part, we have the adaptive solutions, where we'll find information on what we can do, which is kind of the same information that I told you before in my presentation, but with a more detailed catalog with strategies that you can apply. And then we have the possible actions, which it has this same format as in a map format, where you can see the different solutions. And then over here on these three dots, you can go back and repeat the guide tour in case you miss something. And of course, you can also download the shape files of these maps in order, if you want to check them in your own GIS software. Okay, so I would like to say something regarding the climate scenarios. This is our latest functionality that we deployed last week. And here you can select the different climate scenarios. So we have 4 of them, and we have 2 time frames. Okay. So right now, when you are going to test this application, we only have available one future climate scenario, which is this one for this selected time frame. And in the following weeks, we are going to have updated all the others climate scenarios, okay? So here you can use these toggle buttons to turn off and on the different layers. So let's wait a couple of seconds so it finishes uploading. Sometimes it takes a while. Okay. So first, for determinants of hazard, you see that we have this analysis for the whole Athens metropolitan area. But then if you go to the vulnerability and exposure assessment, you see that we have a census tract level analysis. Okay, so for each one of these maps, if you hover around, you get immediately some statistical information. But if you want more detailed information, you can click on any one of these, for example, this one, and you'll find this statistical information and some static, let's say in a way, information regarding the district name or code, the area, and some information related to the indicator selected. Okay. So you can change that in this drop-down menu. You can select the different indicators, and a new map will be uploaded, and you can consult by clicking on each one of these census tract, and you'll get information. So maybe now what we could do is to explore first this part of the diagnosis, the service for application and let you see the different layers that you have here and activate them and see and consult statistical information. And then after this, maybe you can give us a little bit of feedback regarding on what you think about this part of the diagnosis of the service for application. Lisette, I don't know if maybe we could set a time in order to come back and move on to the next part of the application.
Yes, you think it's the best if you would like to give some time now? Maybe we can set like 5 minutes. I see, or maybe someone has any questions at the moment.
Yes,
Please
of
feel
course.
free to raise your hand, and we can also give you the floor to talk if you need any type of clarification or any questions regarding this part. Or maybe what we could do, Patricia, is continue with the rest of the information and then we give them a bit of time later, as you prefer. What do you think is the easiest?
I think someone just raised the hand. I think I saw something. I'm sorry, I cannot see the Zoom.
Yeah, I think it was probably a mistake because there is no raise hands now.
Oh, okay. Okay, so
Let's
okay,
say
maybe we
three
can.
minutes. Let's say 3 minutes. Okay.
Okay, let's give some minutes. Okay, 3 minutes, and then we can move on to the next part of the application. You also will see that you can overlap different layers. For example, this is the urban heat risk layer, and you can compare with the maps that you have behind. So one thing about the exposure layer, one of the indicators that we have here is the energy demand for cooling. So you see that we have some geometries missing here because we have omitted those that we do not have any data. And this is one of the things that Michael mentioned before about the Piraeus. It's missing some of the building data, and which is very important in order to complete in a high level the service for application. But we think that this is enough in order to review how we can use this data and how useful it can be. So if you hover around, you get the total energy demand cooling per meter square. And if you click on any building, this window will come up and you get a little bit of more information regarding that specific building that you selected, such as the type of use. In this case, is a residential building, the year of construction, the number of floors, building height, the footprint, and the total build-up area. Then along with the energy demand, we also have the population density, because as you remember, the exposure, this determinant of risk, is constructed from the perspective of who and what is exposed to urban heat. So in this case, we have used these two main indicators, the one of the presence of people translated into population density, and the other one on buildings that have the higher energy cooling demand. So here, for example, you can see where are concentrated the areas most populated here in the municipality of Piraeus. And you can also consult the number of male and females that are living within that census tract. And here within the climate scenario, you see that once you have selected the one that you want to check, you click on confirm. You have here a description of the climate scenario, and also you will get some an information compare of how the severity, the urban heat severity is going to change across time. Okay, so right now we are at the future climate scenario, the 2.6. And for example, this under this climate scenario, we have these urban climate zones. And Piraeus is situated into this one over here. And you can see that this area, this urban climate zone, will be a 18% more severe during warm month and 27 less severe during cold month compared to the 2023 baseline. Because we have used the citizen weather stations data of temperature and relative humidity from that year. So that's our baseline, and we are comparing the future climate scenarios against these data of 2023. So you get that information for the different urban climate zones. Okay, so maybe we can move to the next section, the adaptive solutions. Okay, so once we have explored all the layers for the analysis of the urban heat risk and its determinants, and also the climate scenarios, here in adaptive solutions, we have this introduction where it explains why adaptation is key to a more sustainable future. And then on what can we do, we'll find the catalog that I mentioned before. So I don't know. Okay, now it's uploaded. So these are the 4 categories that I actually mentioned during my presentation on what can we do from the perspective of urban heat. So we talk about collecting heat, evading, deviate, and reduce. And for example, if we go and click on evade, we'll have this explanation about how to deviate, and also 2 types of strategies, one of the solar protection and other one related to heat prevention. So if you click on solar protection, for example, you have 3 different scales on how you can apply these solutions, okay? Of course, not all strategies are available at the 3 scales because it depends on how we can act and the type of solution. But those that do have available some strategies, it will be, you will find it here, okay? And here, for example, you have the objectives of applying these strategies, and then the actions that you can deploy within your city. And if you click on read more, you'll have this more like a specific information regarding the solution, with a description and some of the variables that you need to consider for its implementation. And this is very important, you can see here some of the possible limitations for the implementation in terms of maintenance, socioeconomic, technical or normative, and management. And then some recommendations. You can always go back and see and consult from this catalog the different types of actions and click on read more in order to have more information. So I'll give you 3 more minutes so you can explore this part of the adaptive solutions, so you can consult the catalog and see what type of information you can get from here, and then we'll move on. Here, for example, we can see that for the heat dissipation, we do not have a specific actions at the city scale or building scale, but we do have some of the solutions for the human scale. In this case, the objective is to give citizens tools for heat elimination. And this is a proposal of what type of action you can apply. In this case, distribute individual fans for use on the street. So if you click on read more, you get specific information related to that action. Okay, so now we can move in this same section of the adaptive solutions. We can go to possible actions when now we are going to be redirected again to this format of maps. So the original idea is to have this catalog of possible solutions also available in this map, let's say, format, so you can visualize it in your own municipality. In this case, we have uploaded a total of 3 solutions that are already in our catalog that we were looking at before. Of course, we don't have all the solutions deployed here because that's a lot of information, but just to give you a glance on how this can be used, okay? So for example, now here in this section, you have the possible actions. Then you have the type of strategies. In this case, we have how to evade heat. And In specific, we have the solar protection, which you can find some solutions at the city scale and the building scale. So let's click on this one for the city scale, which is to increase vegetation coverage in public spaces. It takes a while to upload the data, and I think it also depends on the velocity of the connection. Okay, so now that this layer is now available here, you can see that in the map you will get those areas where it's being prioritized where to increase vegetation, okay, to coverage in public spaces. Of course, this is only let's say like a recommendation, because in every case it's going to be different, and usually you need to take into account some limitations, especially for the normative, the space that you need to deploy that action, etc. But these are like these potential areas where you can deploy the solution. And on the right side, you get the information that we were looking at in the previous section of the catalog. So it's the same information, but you can have it here directly in a map based interface. So you will get the objectives of this action, the description, and what you need to take into account, and the possible limitations that you may encounter when applying this type of action, and some recommendations. You can then deselect this action from here again, and then you can consult the other solutions. In this case, now we are moving to another scale. We were looking at the city scale, how we can increase vegetation, and now we are looking at the building scale, as how we can apply a rehabilitation of rooftops to increase reflectance. And again, we'll find here a description and more detailed information of the action. And in red, you will see those buildings that are prioritized to intervene here, okay, to deploy this action. So you can find where to act first, where to apply the solution first, because we understand that time and resources are limited. So that's why it's important to detect these areas that should be where we should be apply first our solutions. And then finally, we are going to move to another strategy, which is heat prevention. In this case, we are going to look into to create an action plan for climate shelters and climate alerts. So here we have identified potential places that could be transformed as climate shelters during, for example, a heat wave. Here you have some specific information to deploy this action. And if you click one of these pins that you can find in the map, you can see the name of the shelter. For example, here we have the Piraeus Municipality Library. And we know that maybe at this point, they are not considered as a climate shelter right now, but these are potential shelters that can be converted to. And if you click on this, you will get to Google Maps, so you can find it and you can get the direction how to get there. Then finally, if you're interested in to download any type of the maps that we have created for this analysis, you can click here on the three dots in the upper side and click on download shapefiles, and you will see all the layers that are available for you to download. And then you'll get that data that you can see in your own GIS software. And we believe that this can be very useful for the municipality purposes, so they can see but themselves in their own GIS software and combine it with other type of data that they may have, or also for academia purposes. And one thing that I forgot to mention is that coming back to this diagnosis section, when you activate the climate scenario, you can download the weather files associated for each one of these urban climate zones. If I click here, you get some information of the urban climate zone regarding the severity expressed in this unit, the cooling degree days and heating degree days. And here, if you click on download weather file, you will get the weather file that you can use in your own building energy models. Okay, so I don't know if anyone has any question, or if you need some more time to keep exploring the Service 4 application.
Maybe in the meantime, Patricia, we have a question internally that I don't know if it's public, but I can read it for you. I don't know if it would be maybe to hear your perspective, Patricia, or perspective from the Piraeus municipality, from Michael, because the question says, what are some of the key outputs or insights that the service provides, and how can city planners or decision makers use them in practice?
Mm-hmm. Okay, so I would say that one of the key features that we have from Service 4 is that through the analysis of urban heat risk maps and also of its determinants of risk, you can find areas most at risk. So you know where should you act first. Okay, because of all the limitations, specifically for resources and also for professionals that you need to deploy these actions in the city. And also, besides this diagnosis, where you will find which are the areas most at risk, you can get information from the social, economic, and demographic perspective. So you have, let's say, a characterization of the people that lives on the municipality, and that may help to better approach the type of action that you should deploy in a specific or given area. And another key output is the catalog, the solutions catalog. So you can have it for different scale to deploy at the city, at the building, and at personal level. And it will also be classified in the way you want to act, or what is the purpose. You want to deviate heat, you want to protect from heat, and also to have the possibility to visualize these solutions in a based tool. So you can actually see where you can implement that type of action because of their own limitations, specifically for the technical, mostly for the technical limitations. And the last key feature of this service is to have the option to download data and the results that we have created during this deployment of the service, which you can use personally in your own software. So it's not just about using the service for application, but how the results can be exported for your own work, let's say.
Perfect. Thank you, Patricia. I don't know if Michael would like to add something else to this
Yes.
question.
From our side, of course, the necessity of the tool lies in identifying the areas in need of intervention. So urban planners can make this intervention in municipal buildings, but also our funding strategy for the next programming period may focus on these areas, both in terms of municipal infrastructure, but also on incentives to the private sector or programs regarding energy and climate focused on citizens. So this is the first aspect of the that Buildspace Service 4 gives us an added value. And the second, and maybe more important in the near future, is the ability to having these baselines, having this information, having this data and the analysis regarding heat risk and vulnerability, and feeding it into the city's digital twin that is actually in plans of construction at the moment in procurement phase. So based on this information and the models of a digital twin, applying and simulating the applied intervention can show us the general effect that this may have in the city. So we have the baseline information based on the analysis. We have the prediction regarding the years 250 or 280 as made by this tool. But we have this prediction based on specific scenarios. Having the ability to simulate in a digital twin even more scenarios and even more specific changes in what happens in the city can actually lead to even more detailed infrastructure recommendations from our urban planners for the municipal council to decide on.
Thank you. Thank you both for your answers. I think they're really valuable and seen from the perspective from both parts, service developer and the put into action the municipality itself. So before we close this session, I don't know if your participants have any more questions, any more doubts about the service, or any kind of feedback that you would like to provide during these minutes. If you have, please feel free to write it in the chat.
If I can ask something from Patricia, because most people have seen the tool, but if someone goes a week from now to use the tool, maybe he won't remember. If Patricia can show us in 1 minute or 2 minutes the guided tour, that will probably help people when they run it in order to recall and remember what each part of the solution does.
Yes, of course. We can do now the guide tour, but also I would like to say that during this month we will also send a step-by-step guide. So you also have that document that it will support you in the future in case you wanna to check how to use the different functionalities of the service. Okay, so I will share again my screen so we can do the guide tour. Okay, so the guide tour, you will find it here when you enter for the first time in the service application, but also after, if you wanna to do it again, you have it here in the 3 dots in the upper side of the screen. Okay, so let's go with it. So in the step 1, we have, it says, let's start by exploring the first section, diagnosis. Here you'll find interactive maps that visualize urban heat risk across the municipality, which is the actual screen that we are looking at. And step 2, in this sidebar, you can select present or future climate scenarios, which have an impact on how the climate severity will change over time. In the urban heat risk map of the Municipality of Piraeus, we have the updated automatically based on the climate scenario that you have selected, and you can hover around the census track and to click on explore data. And now in the determinants of risk, urban heat risk depend not only on the hazard itself, but also on vulnerability and exposure to it. Here you can explore all indicators and explore data at census tract or building level, depending on the layer. If you find any of the maps useful, in this section you can download the layers and view them in your own GIS program in the download shapes files. Now you can explore how we can take action in our cities to adapt to urban heat in this section of adaptive solutions. In this section, a variety of possible solutions for adapting to urban heat have been compiled. These have been compiled into 4 categories: collect, evade, deviate, and reduce heat. And now in possible actions, you can explore priority intervention areas within the Municipality of Piraeus based on the type of solution recommended for adapting to urban heat. If you want to revisit the urban heat risk maps or change the climate scenario, just click on the diagnosis button to get back. And that's it. Now you can you know how to get around the application and get the most out of its tools. You can return to this tour at any time from here. So that's the guide tour, and we can complement this information with the step-by-step guide, which it will contain more specific directions regarding the application.
Thank you, Patricia.
Thank you.
Any more questions or doubts from the in-presence participants as well?
I think there's nothing more from here.
Perfect. So with this, we can give this session finalized, and we can go to our next part of the webinar, in which I would like to share my screen. Now that you have the chance to see the tool, to use it by yourself, I would like you to fill a really short survey to understand how the tool was for you in terms of if it was easy to use, if it was it's friendly, or what kind of expectancy do you have from the tool, and if it met them as well. So I kindly ask you to scan this QR code and go through the questionnaire and let us know what you think about this. It would really help us not only to understand how this session went, but also to understand how the tool is developing. Perfect. Thank you very much. Yeah, I see them coming. Okay, so I think with this we could start finishing this event. So first, for our online and our in-presence participants, thank you for joining us in both modalities, and thank you for both being so patient with us. Through this event, we're seeing how Buildspace is helping cities like Piraeus addressing urban heat through innovative tools such as the service regarding urban heat analysis and resilience. This pilot highlights how data, technology, and local action can come together to build more climate-resilient urban environments, and we hope that this session has inspired you to consider how these tools could be applied and replicated in your own cities if you're connecting from a different place. Regarding this, I would also like to remind you that we have an open call for replication feasibility available in our website for those, specifically for those cities that would like to replicate this service in their areas. And we can explore together how Buildspace can do this in your towns. So feel free to reach out if you would like more information. It's available in the website, in the social media, but we're also available through an email. And stay connected with the project. We invite you to keep following us and keep growing and keep spreading why Buildspace is so important. So thank you again for your participation. And with this, we close this event. Thank you for joining us.